Hi, Calculus 1 students. So I'll put a series of videos, which is pretty much the class that I had to dismiss. So I will redo it pretty much in its entirety. And I will do this until probably something like 6 o'clock. So to pretty much say that I'm covering the time that I should have covered. So, okay, so how did the class start? We saw two scenarios in the previous class on how a limit could fail to exist. So, it happens, for example, when the value of what that f of x approaches depends on how the x value is approached. So, for example, we saw the example that we saw, when x was approaching -1 from below, the function was approaching 2. Whereas if x was approaching -1 from above, the function was approaching 0. So since these two values are different, we say that the limit does not exist. And number two that we also saw last class was that the function was growing or sinking without bounds. Okay, so this is actually the important wording. Okay, as the x value is approached. Okay. So, for example, as we approach 0 from either sides, as you can see, of the function of this function f of x. Now, as x is approaching 0 from below, then the function is blowing up, and the same thing is happening when x is approaching 0 from values above. The function is also blowing up. So remember that we have a way to write this down. We write this as the limit as x is approaching 0 of f of x is infinity. Okay, remember, infinity is not a number. When we write this, we are meaning exactly this, that f of x is growing without bound when x is approaching 0. So in this first video, we will just recap the third case in which a limit might fail to exist. Okay, so now I'm going to erase everything except the title. So number 3 is f oscillates infinitely fast as the x value is approached. So this happens in the example. So example, f of x is equal to sine of 1 over x. Okay? So we would like to know what is the limit as x is approaching 0 of f of x. Okay? And if we replace values inside that function, okay, so if, so let's actually sketch the table. And I'm not going to use too much value, so here's x and here's like f of x. So remember, if you try to punch in 0, the function will be undefined, okay? But now let's approach 0 from below. Okay, so I'll give, let's say, 3 values. I'll give like -0.5, then -0.1, and then -0.01, I believe. Or 001, it's actually better. Like it serves my example a little bit better. So you will see why, okay? And the values of f that we have, so we have -0.91, so I'll just use 2 digits, I think. Then we have 0.54, and then we have negative 0.82. Okay, and above, so we do the same thing. We're closing in 0 from above. So we have like 0.1, and here we have 0.5. So all of these numbers just turned out to their positive counterpart, actually. That's what happens if you replace into the function. So regardless of the side, so if you approach 0 from below, it seems from above, but it's just that the table is ordered like this. So if you're approaching 0 from values that are below 0, what's happening is that f of x like oscillates between -1 and 1, but it's in neither case it's approaching a very specific value. As you can see, it does the same thing when x is approaching 0 from above. So in this case, f of x also oscillates. Okay. But that's it. The main message is that in neither case, it approaches a specific value. It just oscillates past any kind of value it can take. And because of this reason, we say that the limit as x is approaching 0 of f of x does not exist. Okay, and I want to finish this video by just sketching what this function looks like. Okay, so when x is a very large negative value, the sign will be negative. So it will start like it will start somehow like this, and then it will oscillate. But what's important to know is that first of all, it is stuck between -1 and 1. So I should sketch that to begin with. Okay, so let's say that this is -1. So it will somehow start here, then it will hit the -1, then it will oscillate, but the period will become bigger and bigger. So eventually near 0, it's gonna go like crazy, and then eventually it's gonna get smoothed down. Okay. So so that's what's happening, right? As as 0 is approached from below, the function just goes like so. Like it's actually hard to sketch, but there you go. Like it does this, right? So it's not approaching a specific value, and the same thing is happening from above. All right, I hope this video helped you. In the next video, where I'm gonna talk about one-sided limits. See you there.